So welcome everyone, and today we have one fixed motive in our mind that we are going to solve OPAMP quiz questions. So there are 20 questions, and we are going to do it selectively. That the questions which are new for us, we will do that. Okay. So let's begin with our first problem. So can you tell me that is this based on the OPAMP live class 1 or live class 2? What is it? So we have a circuit here, and we need to know what is the amplitude of the output voltage. So what can we do here? So the very basic concept I want you to remind is that we studied that gain. So let me reduce the pen size. So gain is equals to V output by V input, and V output by V input is given by impedance of the feedback divided by impedance of the input. In feedback, you have two people connected in parallel. So impedance of feedback is given by XC into R feedback divided by XC plus R feedback, because the two things whenever connected in parallel, their net capacitance is written like this. Sorry, net resistance is written like this. And XC you already know is given by 1 by J omega C, and RF you can clearly see is given by 1 kilo ohm. Okay. Similarly, input impedance is given by 1 kilo ohm, and that's it. So if you use all of these values, and input voltage you already know is 5. So you can clearly see here 5, and you just use this formula and you solve your problem. So is it okay? Can you all solve it now? Yeah. What do you say? Right. C option you are saying, which I think is correct. So can you all solve it now? Is it fine now? Can I move to the next problem? Right. It's a mathematics thing now. Okay. Okay. Next problem. The power absorbed by the 2 kilo ohm resistor in this circuit is given by. So what is the power on this circuit, on this resistor, this 2 kilo ohm resistor? And okay, so this is something beautiful. So I would say that a good question. So power across any resistor is given by two formulas. Either you do I square R. So if you know the current in that resistor, you can do I square R, or it is V square by R. Okay. Or if you know the voltage across that resistor, that is also fine. You can do V square by R. Okay. Integrated differentiator formula in such question. Can't we use direct in question 1 or question 2? I think you are talking about 1, right? No, in 1 you don't have a pure integrator or differentiator, right? In 1 you have both, no? So capacitor and resistor both are there. So you need to find gain in this questions. Yeah. Yeah, if there was only one capacitor, then you can say it's differentiator or a integrator.
बट
Yeah.
जब रेजिस्टेंस साथ में होता है कैपेसिटर के तो हम उसे लाइक प्रैक्टिकल इंटीग्रेटर करके कुछ बोलते थे राइट
अब वो कुछ भी बोल सकते हैं, बट बेसिकली द जनरल फॉर्मूला इज वी आउटपुट बाय वी इनपुट इज जे फीडबैक बाय जे इनपुट, and that is most general thing you will find in any engineering book. Maybe that is also there, that some practical thing can also be there,
ओके
but ये most general way है. Yeah. ठीक है. I won't say that is wrong, that is also correct, but yeah, ठीक है. Okay, let's see now what we can do now. So here we have 2 kilo ohm resistor, and we need either current across this or we need voltage across this. So I'm going to pause the recording and I'm going to give you 2 minutes to think how you can do it. So try this. So this question is based on the voltage follower. So let me make a voltage follower first of all. What is voltage follower? Okay, so voltage follower looks something like this. So you have a, first of all, you have a op-amp. Sorry, you have an op-amp. Let me make a good one. Yeah, this is an op-amp, and you have a negative side, you have a positive side. So let me make positive side up, negative side. You apply the voltage on the positive side. So you apply V input here, and this is your V output. And then what you do is just connect the negative side directly to the output. Directly to the output. So you can clearly see that I have connected it directly to the output. So the gain of this kind of situation, gain means V output by V input, is basically J feedback by J incident, and this comes out to be 1, because all the voltage which is out there, whatever is your output voltage, all of that is being fed back to the input. So it's completely fed back. So entire voltage is fed back. And JF by JI comes out to be 1 in this case. So gain in this question will be 1. So V output and V input will be equal. So in the output also you will get an input. In our question also, this is a sort of a voltage follower. Now, if you carefully look at it, if you can, is it a virtual ground concept? Virtual ground concept, yes, it is. Yeah, because if this is V input, this is also V input. And if this is V input, then this is also V input, and V output and V input become same. Yes, exactly. You are exactly right. Now, in this question, we have to be very careful with what we are talking about, because we have to be very, very careful in this situation. First of all, what is the output of our voltage follower? So if this is my voltage follower, let me write this. If this is my voltage follower, then this thing is my output. But what is my input as such? Because my input is not only 6 volt, because you carefully see that my input, this thing is 0 volt, this thing is 0 volt, and this is being fed in. So let's say this thing is 6 volt. But then you see, I am also doing some feedback in the positive side as well, right? So it's not that only negative side has been feedback. Yes, if this wire was not there, then I am fine with it. But this wire is also there. This wire is also there. So my positive side, my input is also being fed back. Some part of it is fed back. So what can I say very certainly about my voltage? Very certainly about my voltage. So because it is also fed back. So it is also, so my output, this whatever is here. So let's say the voltage at this point is VA. Now that VA, some part. So what is a voltage around 4k ohm. So voltage across 4k ohm is VA minus 0, because the voltage here is 0. On the other hand, the voltage across 2 kilo ohm is VA minus this thing. Let's say this is V output. So VA minus V output. But what is V output? V output is equals to V input. And the question is that what is input? Is input 6? Is input 6? That is the question. Is my input 6 here?
We for the
Yeah.
output we only need the the potential difference
No,
across the 4 ohm resistor,
I
right?
get your point. I get your point. I get it. Yeah, it was a good actually analysis. Yes. So what is being done here is, see, what he's trying to say. This is 6 volt, perfectly fine. This is also 6 volt, perfectly fine, because it is a voltage follower. So this is also 6 volt, perfectly fine. This is grounded, so this is 0 volt, perfectly fine, and this is 0 volt, perfectly fine. Now, whatever current comes from 6 volt, let's say, the current will come and it will directly go down, because the current cannot go this side. The reason being because current cannot go to the open side, right? There is nothing here. Yes, if I use it, if I connect it with something else, then maybe the current will also go on this side. But for a moment, this is open. So whatever current comes here, the current goes down. So I is here, the same current I is here. So both of them are in series. Now I can find this current actually. And how can I find this current? Because the voltage difference between this point and this point is 6. 6 minus 0 is 6. And again, the resistance of from this point to this point is also 6 kilo ohm. So 6 by 6 is basically 1 milliampere, because kilo is 10 to the power 3. It goes to minus 3, so it becomes 1 milliampere. And then I can find the power by, and using the power I can do I square R. I square R, and current is 1 milliampere, so it is 10 to the power minus 6. R is 2 kilo ohm, so 2 into 10 to the power 3. So this thing comes out to be 2 into 10 to the power minus 3, which is 2 milliwatt. So your 2 milliwatt will be the correct answer. Okay, so this is your solution. Yeah, any doubt here, please? What do you say? So this is a case. So 6 is perfect. So 6 volt is here, not here. And this 6 basically goes down like this. Perfect. Okay. So we should not think about this point. We should basically know this 6, this is 0, so directly comes here. Done. Nice. Yeah. Is it clear, all of you? I hope it is. Yeah. Okay. Let's go to the next part. Next question. In in this case, try this problem. So we have 1 volt here. If this is 1 volt, then this thing is also 1 volt. This thing is also 1 volt, and so on. And if this is 1 volt, then because why this is 1 volt, I'm saying, why this point is also 1 volt, because this point and this point are simply connected by a wire, and if they are simply connected by a wire, then both the points are same, which makes sense. Yes, Anita, it's D. So if this is 1 volt, then this is also 1 volt. And now it's very tricky. Why it is tricky? Because this is 1 volt and this is 1 volt. So no current will come. Because if this point is 1 volt and this is also 1 volt, why will any current come? Because current is voltage difference by resistance. And there is no voltage difference, because if I look at this 10 kilo ohm resistance, both sides of it are at 1 volt. So why would any current come? So no current will come. So if no current comes here, similarly no current will goes here. So then everything will be one. So no potential drop is, if you start with one, it is one, it is also one. Why I'm saying everything is 1 1 1? Because no current. So no current means no potential drop. Because potential drop is given by IR. If there is no current, there is no potential drop. So if you start with one, at the next point also one, at the next point also one. So here also the voltage is 1 volt. Here also the voltage is 1 volt, because the potential drop is not happening, because the current is not flowing. So this circuit is basically no current flow. So there will be no flow of current in this circuit. Current will not come from this part to this part. So this will be at 1 volt, this will be at 1 volt, this will be at 1 volt. Everything will be at the same voltage. As a result, there is no flow of current. So option number D is correct in this case. Any doubts, please let me know. Yeah. Perfect. Fine. Yeah. Okay. Then comes the fourth question. Very quickly, very simple question. This is, I think, one of the most simplest question. What is an output voltage? But tell me very quickly, what is an output voltage?
6 volt.
What is out? 6 volt. Why you are saying that output is 6 volt? Because if this is 2 volt,
Yeah, that
then
is that above also 2 volt.
above also is 2 volt, and then you can do the maths. So this
Yeah.
you can easily do, and I don't think this is needs to be discussed. So this is an easy problem, you can do all of that, right? Okay, good. Next question, fifth one. Yeah, any discussion needed on that? I think it's again a simple one, but what can be done for this one? Again, the principle of virtual ground will behave. So you can clearly see this thing is 2 volt. If this is 2 volt, then this thing is also 2 volt. Right. So this thing is also 2 volt, and then you need this current, this current. So first of all, whatever current is here, the same current will be here, because no input current can be there. So first of all, you can find this current, and how you can find this current? I1 can be written as voltage difference. And what is a voltage difference? Voltage difference is 1 minus 2, so which is 1 divided by 2 kilo ohm. So 2 kilo ohm. So 2 kilo ohm here. So basically you can find it as 0.5. Am I doing something wrong? 2 minus 1. Perfectly fine. This is also 2. This is 1 volt. It's 1 divided by 2 kilo ohm. Is 0.5 milliampere, or you can basically say 1 by 2000. Okay. And okay, that's okay. They are not asking for the current, they are asking for the voltage. Sorry. Okay, so the same current will be there in I2 as well. So I2 will also be same. So I2 is also same. That how can you write I2? I2 can be written as V output minus this voltage. This minus this. So V output minus 2 divided by 8 kilo ohm. So this can be written as 4 equals to V naught minus 2. So V naught can be written as 6 volt. So answer to this is also 6 volt. So again, a easy question. Okay. So again, easy problem. I think if you have given the quiz, you should have scored it completely. Think about this question. This is really good question. Okay, not really very difficult, but yeah, some good quality. If you understand the sixth problem, it means that you have understood some of the concepts of OPAMP. And I think sixth question has to be done very well. Let's do that. So this point is 5 volt, and this point is 0 volt, and this is also 0. And let's find the potential at this point. Very clearly, I can see that 16 ohm and 2 ohm are parallel. Why I am saying that? Because 16 is connected between 5 volt and A. 24 ohm is also, so it's not 2, it's 24. So 24 ohm is also connected between A and 0. No, they are not parallel. Actually. Sorry, it's not parallel. Right? No, they are not parallel. No, they are parallel. No, they are not parallel. They are in series. Because whatever they are not parallel, sorry, they are in series. Sorry, my mistake. They are in series. Why they are in series? Because if you see, whatever current comes from here, the entire current has to go down because no current can enter the OPAMP. No current can enter the OPAMP. So whatever currents come from 16, the same current goes to 24. And whenever the current is same in two resistors, they are said to be in series. Okay. So what is a voltage drop in? So let's first find the total current. So the total current is given by total voltage 6 by total resistance. 16 plus 24 is 40. So total current is 1 by 8 ampere. And let's find the voltage drop across 16 ohm. So voltage drop across 16 ohm is IR. I is 1 by 8, R is 16. So it is basically 2 volt. So when you pass through the 16 ohm, 2 volt is dropped. This is known as the voltage drop. Okay, so 2 volt is dropped. It means you start with 5 volt and 2 volt is dropped. So remaining is 3 volt. So that is why the voltage at this point is 3 volt. So if the voltage at this point is 3 volt, then you know that voltage at this point is also 3 volt. And since it is a voltage follower, so voltage at this point is also 3 volt. And then the same concept I can use that whatever current comes from here, the same current will go down. Same current will go down. And how much current will be here now? The current here will be total voltage 3 volt. And the total resistance, which is 12 plus 8, which is 20. So it comes out to be 3 by 20. And what is the voltage across 12? So voltage across 12 is V output, which is given by IR, which is 3 by 20. R is 12. So you can clearly see R is 12. Okay. And this comes out to be, if you cancel with 4, so this is 3 and this is 5, 9 by 5. 9 by 5 is what? Sorry, am I making any mistake? 9 by 5. It's right? 3 by 20, perfect. And then V equals to IR multiply by 12. सही है ना? So 9 by 4 नहीं 9 by 5 ठीक है ना? 9 by 5 is 1.8. Right, 1.8. Yeah, 1.8. So answer should be 1.8. Perfect. So let me repeat this solution very. I think you should revise this question again and again before your exam. Okay. So what should happen in this case? This is 5 volt. If this is 5 volt, then whatever current comes here, the same current goes down. So let's find the current in this side. So we found that current, and that current comes out with total voltage, which is 5 divided by total resistance, which is 16 plus 24, 40. So the current comes out to be 1 by 8. And then you find the voltage drop across 16. So voltage drop across 16 is given by IR, and I is you have calculated as 1 by 8, R is given by 16. So this comes out to be 2 volt. So voltage drop is 2 volt. So 5 minus 2, what is left? 3. If this is 1. Then can anyone tell me that which circuit is this very quickly? Which is this circuit? It's a very simple one. What is it called? Adder. So it's a adder circuit, voltage adder circuit. And you can clearly see what will be the final answer to this. 3 plus 2 plus. So you have to think. Multiply by gain also you have to do. So you can do this question very easily. Very, very easy. Just direct use of the formula. Nothing to discuss here. Then again, this question, what do you say? Is it doable? Very simple question. Again, I would say one of the easiest problem. So again, you can say voltage division. Okay, so find everyone find the answer to 8th question. So you have to use the voltage division rule. So what is your total voltage here? Total voltage is 2, and it is divided between 2 people, 2K and 4K. So you can say 4 by 2 plus 4, 6. So it will be 4 by 3 volt. The person who don't know what is voltage division rule, so this is voltage division rule. If anyone does not know voltage division rule, please mention me in the comments. I will explain you. Okay. If although I have done it in my classes, but if you don't know, please mention in the comments. Okay. Okay. So the voltage at A and B is 4 by 3. So voltage at A is also 4 by 3. And then you can use a simple rule that whatever currents comes here, the same current goes here. So 2 minus VA by 1 is equals to VA minus V output by 4. And from there, VA you already know is 4 by 3. This is also 4 by 3. And then you can easily solve the question and your V output will come out to be something. Okay. And this will come out to be exactly as minus 4 by 3. So your option number C will be correct. Okay. Very simple question. Again, this is also very easy problem. 2 ampere current is coming from here. So the same current will go here. So this will also be 2 ampere. If this is 6, then this is also 6. If I already know that the 2 milliampere current goes here, then I can easily do 6 minus V output divided by resistance, which is 2 kilo ohm, is equals to 2 milliampere, which is 10 to the power minus 3. So 6 minus V naught is equals to 4, and V naught is equals to 2 volt. One of the most easiest questions. So V output will be 2 volt. Any doubt in this problem? Yeah, perfect. Okay, good. Now, 10th problem is something which we have to discuss. I think this is one of the interesting problems. So please think of it and then. So let me explain how to do this question. So first of all, the voltage at this point is 5 volt. It does not matter. The voltage at this point is 0 volt. Again, it does not matter. If voltage at this point is 0, then the voltage at this point is 0 also. Again, it does not matter. Let me show you the transistor. So this is your transistor. This is known as base. Okay. This is known as emitter, and this is known as collector. The voltage at collector is 0 volt. The voltage at base is also 0 volt. And voltage at emitter is V output. V output. And you know that there is a base emitter voltage, VBE. If you have ever done transistors in your life, no, it's not common base, it's a common emitter. Okay, it's a common emitter configuration. If you have ever done the transistor in your life, then you know that for silicon, base emitter voltage is given by 0.7 volt. So this side is plus and this side is minus, and the difference between them is 0.7 volt. Now you can do Kirchhoff voltage law. How you can do Kirchhoff voltage law? So you start from 0, so you write 0. You start from 0, so you write 0. Then you go in this direction. So you see positive first. So you see positive first. So if you see positive first, then you write minus 0.7. If you see negative first, then you write plus. If you see positive first, then you write negative. Okay. And this we talked in the, I think so, in the Kirchhoff voltage law class as well. And then we come down and we reach to the V output. So equals to V output. So V output simply comes out to be minus 0.7. Okay, and that is your option number B. So any doubts in first 10 problems? So this is the end of your MCQs, and now I will go for MSQs. Any doubt in first 10 problems? Any question you want to repeat? Because MSQ are little difficult and we have a good discussion. Let's start with the 11th problem and think about this question, and then we will discuss it. Okay? So let me explain it a little bit. There are two diodes, diode number 1 and diode number 2. And there are two resistors. One resistor is here, one resistor is here. It is like there are two feedbacks. One feedback is given by the diode and another feedback is given by resistor plus diode. So one feedback is this and one feedback is this. Okay, so there are two, basically kind of two feedbacks are there. And there is an input voltage here as well. Voltage at this point will always be 0, perfectly fine, because this is virtual ground principle. If this is 0, then this is also 0. And this is obviously V input. And V input is changing. Sometimes it is positive, sometimes it is negative. So V input has two possibilities, that it can be less than 0 and it can be greater than 0. Okay, because it's a sinusoidal. So sinusoidal means that it can be positive as well, it can be negative as well. So half of the time it will be less than 0 and half of the time it will be greater than 0. So you have to tell that what happens if the V input is less than 0 and what happens if the V input is greater than 0. Okay, so have a think of it, what will happen. Okay, so what do you think will happen here? See that. So this is a very interesting problem. So let me explain this problem to you all. And I think this is how we solve the diode problems. I think all the diode problems using the same concept. Almost similar concept. So you have to predict about the output initially beforehand. So you see the concept. So at this moment, at this point, the V input is a voltage. And this point always remains at 0, because if this is ground, so the upper point is also ground because of the principle of virtual ground. So if this diode is biased, reverse biased or forward biased, is not going to be decided by this 0, because this is always going to be 0. Okay. Now let's think about it. If the V input is greater than 0, so let's say I say the V input is greater than 0. Now think about the two terminals. So I give a positive voltage. And I am giving my positive voltage to the non-inverting terminal. Sorry, I am giving my positive voltage to the inverting terminal. So what does inverting terminal do? It makes positive voltage as negative voltage. Do you all agree with this, first of all? So if I give a positive voltage to a inverting terminal, it will make a positive voltage as negative voltage. Is it something you agree? It does not matter how much negative, but it will make it negative. So if your V input is positive, then your output definitely is going to be negative. I'm not talking about how much negative, but definitely it could be negative. Okay. If this happens, if this so happens, then what happens is that if this is 0, then obviously this is also 0. And if this is negative, then obviously this thing will become forward biased. Why forward biased? Because this side is known as N and this side is known as P. It's PN diode. And if negative side or N side is connected to the negative terminal and P side is connected to the positive terminal, then obviously then this becomes a forward bias. And forward bias means that diode becomes like a wire. So first of all, this diode becomes like a wire. So let me make this circuit. So this thing will become like a wire. So this is a wire. Also, you see, this side will be negative, because if this is a wire, then this negative voltage will be same as here. Same as here. And then this also becomes a forward bias, because P side is 0, higher voltage, N side is negative, lower voltage. So this also becomes like a wire. So this also becomes like a wire. So both of them becomes like a wire. Okay. So if this point is like a V output, then this point is also V output, because in the wire all the potentials are same. So this point is basically V output, and this is also V output. And then I'd make the connections and I say that this is my OPAMP, and this acts like a wire, and this happens like this. This happens like this. So whatever is voltage at this point, that is a voltage at this point. Since voltage here is zero, voltage here is also zero, and again the V output also comes out to be zero. So if the V input is greater than zero, the V output will be zero. So if the V input is greater than zero, then V output is zero. So that is the first option that is going to be correct. Please repeat this thing in your head again, and if ask me any questions if you have. Okay? Ask me any questions. Yeah. So this was the concept here. Now let's talk about the negative side. So if I give the initial voltage as negative, then for the, can we take other part as well? Yes, yes. So then if I take the initial value as negative, then my output will become positive, because non-inverting terminal will shift it, will make it reversed. If this is positive and this is by default zero, from the very beginning everything was zero. In this case, and this is also zero, in this case both the diodes are reverse biased, because N side is connected to positive and P side is connected to zero. So basically this is reverse biased. If this is reverse biased, then everything is reverse biased. Both the diodes are basically reverse biased. So let's ignore the diodes. So it is like a simple op-amp now. So you have an R1, you have an R2, and you know the gain in this case can be written as minus R2 by R1 into V input. Right. So if both the diodes are ignored, then your simple circuit appears, and that thing basically becomes minus R2 by R1 by into V1. That is a gain. Gain, how much is a gain? Feedback resistance divided by input resistance. Feedback is R2, input is R1, multiply by input voltage, which is V1. So that is what your appears. So your option number 1 is also correct. Okay. So that is what the girl was saying initially, that when V input is less than 0, then both the diodes are reverse biased. And when V input is greater than 0, then both the diodes are forward biased, and you will see your circuit accordingly. Any doubts in this problem? Yeah. ठीक है? Any doubt in this problem?
सर पर एक बात मुझे अभी भी समझ में नहीं आई कि जैसे वो जो पी जब जीरो हो जाता है, तो आप कहते हैं कि नेक्स्ट स्टेप में वो क्या नाम है, मतलब कि उसका वोल्टेज हाई हो जाए, ये चीज मुझे मतलब कि क्लियर नहीं हुआ थोड़ा।
सॉरी, क्या, कहाँ से? मैं समझा नहीं, प्लीज लेट मी नो कहाँ पे।
ये सर
इसको पॉजिटिव करना है पहले नेगेटिव करना है? स्टार्टिंग में क्या, नेगेटिव पॉजिटिव, वेरी स्टार्टिंग। ये यहाँ पर मैं नेगेटिव रखूं पॉजिटिव रखूं स्टार्टिंग में? वी इनपुट, सॉरी, हेलो।
यस सर, आप बता रहे हैं। यस सर।
हाँ हाँ, मैं आई एम आस्किंग दैट शुड आई पुट दिस एज नेगेटिव पॉजिटिव? व्हाट इज योर डाउट हियर? आई शुड पुट नेगेटिव पॉजिटिव?
सर नेगेटिव।
ओके, नेगेटिव. Okay, and this is 0, right?
Yes.
And if you put initial voltage negative,
Yes,
then
sir.
your output will be positive, right?
Yes, sir.
This is not clear. This is not clear. Output is, why output is positive? This?
नहीं सर, क्लियर, ये क्लियर है, पर ये पी के
हाँ,
पास जो जब आप कह रहे
ये
हैं
वाला,
कि
ये वाला पॉइंट, ये 0.
जी 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 सर, ये तो
every
ठीक मान लिया कि वो इनिशियल में जीरो होता है, पर
हम्म
पर उसके जो पीछे जो डायोड लगा है, उस डायोड में जो एन वाला हिस्सा है, आप फिर उसको फिर से जीरो कैसे कंफर्म कर लेंगे? मतलब कि ये फिर जीरो, मतलब कि उसकी ये जीरो जीरो के साथ कनेक्ट है, पी भी और एन भी दोनों।
अच्छा, दिस इज कनेक्टेड बाय 0 0. अच्छा, चलो, तो नो करंट फ्लोस हियर, राइट? ओपन हो गया ना?
यस सर।
तो ओपन या रिवर्स बायस में क्या फर्क
सेम चीज है, हाँ सेम
है,
चीज
राइट?
है।
तो वही बात होगी ना फिर. ठीक है, तो खुला ही हुआ है ना, मतलब कोई करंट वहां से नहीं जा रहा. सिंपल. So that's
एक्चुअल में
nothing.
नहीं सर, जैसे मैं कह रहा हूँ कि ऐसे तो लॉजिकली ये चीज सही है, पर एक्चुअल में यही हो रहा है कि मतलब कि जैसे ये भी जीरो है वो भी जीरो है, इसलिए वो कैनवा ओपन हो जा रहा है।
तो एक्चुअली में यही हो रहा है एग्जैक्टली। मतलब क्या है कि यू नीड एटलीस्ट 0.7 वोल्ट। एक्चुअल अगर बात करें तो 0.7 वोल्ट चाहिए टू पास द करंट। वो वही नहीं मिल रहा। अगर जीरो जीरो भी हो तब भी नहीं करंट फ्लो करेगा ना। वन साइड हैज टू बी 0.7, सेकंड हैज टू बी जीरो, तब जाकर करंट फ्लो करता है, क्योंकि डायोड का वो होता है ना, बैरियर वोल्टेज होता है। हाँ,
जी जी
तो
यस।
तो एटलीस्ट 0.7 तो देना पड़ेगा ना डिफरेंस। द डिफरेंस इन दिस केस इज जीरो जीरो, दैट इज व्हाई नथिंग इज फ्लोइंग इन दैट, दैट इज व्हाई इट इज रिवर्स बायस। ठीक है। It is like you are just placing the diode. Diode is not doing anything. Diode is just placed. It has no function as such. Okay. So that is why I'm ignoring that diode in this case. Okay.
थैंक यू सर, समझ में आया।
Okay. Then this is a fact-based question. That an ideal diode should have what? So it should have high CMMR. I will send you one video for CMMR. That video will explain you that what is CMMR. You can just watch that video. It's very nice video from by Ideal Electronics, something YouTube channel like that. It's very nice. You should watch that CMMR thing. Okay, and then you should have. No, it's more than one, correct? Low input resistance. No, input resistance is high. So high input resistance and output resistance should be low. So it should have high CMRR, then it has high input resistance and low output resistance. That are the fact-based question, and you should always keep these facts in mind. Okay, especially if you're preparing for BARC exams like that, these facts can be useful. Okay, now this is something very interesting problem, one of the difficult problems. So let's think of this question. So let's start thinking. So let me first explain this problem, and then we will think of it. So a regulated power supply, okay, regulated power supply shown in the figure shows has an unregulated input. So regulated power supply. So you have to regulate the power supply, means the voltage has to remain regulated. But what happens is that initially there is an unregulated voltage, and it is 15 volt, and it generates a regulated output. Here the voltage is generation of this is basically, it's like a, you can say it's like a regulator. This circuit is behaving like a regulator. That fact does not change any mathematics for us. Okay, so 15 volt is an input and we need output. Use the component values shown in the figure, and we have to answer the four things. What is IZ? IZ means Zener current, because this is a Zener diode. What is the current in IZ? Then PT, PT, what is PT? I think power across transistor. What is a power across transistor? Okay, so we need to know what is a power across transistor. There is a transistor, you can see there. And then V output, what is this output voltage? And fourth is what is IC? What is a collector current? So this current, this is a collector current. Okay, so we have to answer these four questions, and if we are able to answer that, we are done. Okay, in order to answer that, let's write the voltages. Let's start writing the voltages so that we can have some things in our hand. So this thing is 15 volt. Obviously, this is shown here. And okay, this is V output. This is V output. Okay, so let's think. So this will be ammeter current. This will be ammeter current, and this will be base current. Okay, and perfectly fine. Okay, no current can flow here. This has to be zero current. So whatever current comes down, the entire current comes down to the diode. Or whatever current goes up, the entire current goes up. So I'm not going to predict the direction of the current, but if the current goes down, so it will go down from here to here. And if the current goes up, it will go up from down to up. No current can bend towards the op-amp. So if I know the current across 1 kilo ohm, I know the current across Zener, because the current across 1 kilo ohm and the current across Zener will be same. And Zener voltage has 6 volt of Zener voltage. What is Zener voltage? Means whatever current flows through this, the voltage across this will always remain 6. And if the Zener diode is actually reverse biased, then the voltage at this point will be 6 volt. Only then the Zener voltage will be 6 volt, because if the Zener diode is actually reverse biased, I'm not predicting that it is reverse biased, but if it is reverse biased, then this thing has to be 6 volt. And if that is 6 volt and this is 15 volt, then you can predict that the current in this resistor will be 15 minus 6, which is 9, divided by 1 kilo ohm, which is 9 milliampere. So the current should be 9 milliampere, and we are able to answer our first question that yes, Zener current is 9 milliampere because the current in resistor and the current in diode will be same. Any doubt still here? Any doubt still here? So what I did, I said that whatever current is in the 1 kilo ohm, the same current is in the Zener, because no current can bend towards the OPAMP. Second concept which I said is that the Zener diode has a 6 volt. It means if it is reverse biased, then the voltage across it will be 6. And if the voltage across it is 6, then it is 0. And so it means that this point will be 6 volt. And if this point is 6 volt, the upper point is 15 volt. So 15 minus 6 is 9, divided by resistance, which is 1 kilo ohm. So current is 9 milliampere. The same current will go to the Zener. So the current in the Zener will also be 9 milliampere. What do you say? Is it clear, all of you? Perfectly fine. Yeah, please. Any doubts? First thing. Right. What do you say? Yes, no, I can repeat. Any doubt, please?
समझ में आ गया सर?
Okay. If this is 6, please repeat. Okay, sure. So this thing is 15 volt because this is 15. So 15 volt is here. Then the current goes down. So whatever current goes in this resistor, the same current goes to the diode, because no current can enter the OPAMP. Perfectly fine. So if the current goes down, so how? The voltage across the diode is 6 volt. This thing is 0 volt. It means this thing is 6 volt. And now I can find the current in resistor. Current in resistance is voltage difference 15 minus 6, which is 9, divided by the resistance, because the current is given by V by R. Resistance is 1 kilo ohm, so the current comes out to be 9 milliampere. Current in the resistor is 9 milliampere, so the current in diode will also be 9 milliampere. Okay, so that is what we got. So the Zener current is 9 milliampere. So let me remove all of this. And we got 9 milliampere. Okay, now let's come back. So this is 6 volt. And this is 15 volt. If this is 6, then this is also 6. Using the virtual ground, and this is also 6. Okay. Okay, this is also 6, and perfectly fine. Okay, perfectly fine, perfectly fine, perfectly fine. If the current comes down here, let's say some current comes here, then no current can go in this direction, because otherwise it will enter the OPAMP. So no current can go in this direction. So this is not allowed. So the entire current will flow down. So whatever is the current in 12 kilo ohm, the same current is there in 24 kilo ohm. Otherwise, some current will enter the OPAMP, and that is not possible. So no current can come out of here, and no current can enter here. So it means whatever current is there in 12 kilo ohm, the same current is there in 24 kilo ohm. And I know that how much current is there in 24 kilo ohm. And can you tell me how much current is there in 24 kilo ohm? What is the voltage difference? 6 minus 0, 6. Divided by what is the resistance? 24 kilo ohm. So this is 1 by 4 milliampere, which is basically 0.25 milliampere. The same current is here also. If the current in 12 kilo ohm is also 0.25 milliampere, then what is the voltage at this point? What is the voltage at this point? The voltage at this point is V minus 6 by 12 kilo ohm is equals to, what is the current? current is 0.25 milliampere, 0.25 into 10 to the power minus 3. So V minus 6 equals to 12 into 0.25 can be written as 1 by 4. And kilo and ohm, this cancels out and this comes out to be 3. So voltage comes out to be 9 volt. So this thing is at 9 volt. Okay. So again, a good success. So what is V output? So if this is 9, this is also 9. If this is 9 and this is 0, then what is the V output? V output is also 9. And that is our option number C. So is it clear? Is the option C clear? In this option, what I said is that whatever is current in 12, the same current is in 24. And I can find the current in 24. How? Because the upper side of 24 is 6, the lower side is 0. So the current is 6 minus 0 divided by 24. And if I know the current in 24, I know the current in 12. And if I know the current in 12, I can find the voltage in 12. By using V, upper side is V, lower side is 6, divided by 12 equals to current. And that's give me the upper voltage, which is 9. So if the upper voltage here is 9, then the voltage here is also 9, and the V output is also 9. Is it clear, everyone? Yeah, very difficult and interesting problem, but a very beautiful problem. Yeah, what do you say? What do you say? I hope so it is clear. What do you say? Now, can you tell me what is collector current? What is? No. They are not parallel. The first 12K ohm is connected between 9 and 6. The second 12K ohm resistor is connected between 9 and 0. So they are connected between two different points. So both the 12K are not parallel. Okay. Okay. Now I am asking you the question that what is the collector current? If you think carefully, okay, so let me remove all of this. Okay, and let me little bit simplify it. This is collector current, and this voltage we calculated as 9. This is 6, and yeah, good. This is also 9, and this is 0. Right. If you carefully look at it, the collector current will divide into two parts. One is the lower part, and one is this part. So this is known as I, and this is known as I output. So the collector current can be written as I plus I output. I already calculated in the previous case, which is 0.25 milliampere. I hope you remember this. We just did that. And I output can be done by using 9 minus 0 by 12 kilo ohm, which is 3 by 4, which is 0.75 milliampere. So the total collector current is 0.25 plus 0.75, which is 1 milliampere. It means the option number D is also correct. So whatever is the total current coming from the collector, that is dividing into two parts. One is going down, one is going in output. How much current is going down? 0.25. And how much current is going to output? 0.75. If you add them, you get 1. Perfect. The last thing which is left to be done is what is the power around the transistor. So the power around the transistor is given by input voltage across input and output. What is input and output? A meter is an means output. Collector and a meter are input and output. So VCE, and what is the current? IC. What is the voltage difference? 15 minus 9. So voltage difference is 6. And how much is the current? Current is 1 milliampere. So 6 milliwatt is your answer. So this option is also correct. So power is always given by voltage into current. So voltage difference across the transistor is 15 minus 9, which is 6. And the output current is 1. So your power is also 6 milliwatt. Yes, so A, B, C, D, all four are correct. And yeah, any doubts in this question? ठीक है,
सर
most of
ये
the
जो
yeah.
पावर अक्रॉस है उसको सर
हम्म,
अगर हम वीबी इंटू आई भी कर दें तब भी पावर निकल आएगा।
सॉरी क्या करना चाहते हैं?
अगर पावर अक्रॉस ट्रांजिस्टर निकालना हो तो
हम्म,
वीबीई यानी बेस और एमीटर के
no 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 no
मैक्स
no no no
वोल्ट।
basometer, no basometer is not your input and output, right? You have to think about the input and output terminals of the transistor. Input and output is collector and emitter, not base. Base is just for good functioning of the transistor, right? So power is always between input and output, right? How much current you are getting out of the transistor multiplied by how much voltage difference you have given in the transistor. So that is why it is always given by VCE into IC. Okay.
ये चाहे कैसी भी कॉन्फ़िगरेशन के अंदर लगा हो फॉर्मूला यही रहेगा वीसीई मल्टीप्लाई आई सी।
नहीं नहीं, ये तभी रहेगा जब कॉमन बेस कॉन्फ़िगरेशन, कॉमन मीटर में बदल जाएगा ना, कॉमन मीटर में बेस और कलेक्टर इनपुट और आउटपुट हो जाएंगे,
ओके
राइट? इसमें कॉमन बेस लगा है ना, यू सी इट्स अ कॉमन बेस कलेक्टर कॉन्फ़िगरेशन। ठीक है, सो दिस वाज अ वेरी इंटरेस्टिंग प्रॉब्लम, आई होप यू एंजॉयड दिस प्रॉब्लम एंड या ओके। नेक्स्ट प्रॉब्लम 14th. In the circuit shown in the figure below, choose the correct option. The output voltage of this circuit is 17.5 into V input. So we need V output in this case. We need I naught in this case. This I naught. We need means again we need V output. So either V output is this or V output is this. And then we need I dash. I dash is this. I think it uses the same logics that no current should enter the op-amp. So if this thing is V input, I am going to give a hint only in this question. So this is also V. So if this is V input, then this second point is also V input. And if this is V input, then this is also V input. And a very simple logic says that whatever current comes in this, the same current goes down. Okay. So I dash in this also the current is I dash, and in this also the current is I dash. And how you can find I dash? I dash is the voltage difference. So V input minus 0 divided by capital R. Okay. And if you know I dash, then you can know the voltage at this point, voltage at A. Because then you know that in this resistor also the current is I dash. And I dash is given by V input by R. But the current in this resistor should be written like this, VA minus V input by 4R. So from there you can find VA. And once you know, so first of all, this option comes out to be correct. Okay, so D is correct because I dash we calculated as V input by R. Now, you can calculate VA and then you can again repeat the same thing, right? So if this is VA, this is again VA, this is again VA, and then you repeat the same thing and you get V output. I think that this is now doable, right? What do you think? Yeah, हो जाएगा ये क्वेश्चन अब। थोड़ा सा डर कम हुआ ओपैम्प का, आई होप सो। मुश्किल सर्किट देख के ओपैम्प का एक डर होता है काफी
सर
लो पास
ट्रांजिस्टर से
फिल्टर।
डर बढ़ गया।
या प्लीज, ट्रांजिस्टर का डर बढ़ गया, अब ट्रांजिस्टर का कर लेते हैं। 15th question. Tell me about 15th question. Is it low pass filter, high pass filter? Yesterday we did. Is it low pass filter, high pass filter? High
सर
pass
हाई
filter.
पास
So first of all,
हाई
it
पास।
is yes. So it is high pass active filter. And cutoff frequency, you all know, 1 by 2 pi omega c. So I think all of you can do that. 2 pi omega c, all of you know how to do the maths. So if you do the maths, 2 pi omega c, you will get 1000 radians per second. So your option number C will also comes out to be correct. Okay? So yesterday we studied the formula. So B and C both are correct. Okay. Nothing new as such. It's a very simple question, and you can do it. Yeah. Next problem, NAT. Again, if the circuit is used to amplify the sinusoidal input by a factor of 15, I will provide you the lecture, Jyotsna. I will provide you the lecture. If you were absent yesterday, I will provide you the lecture. ठीक है? ठीक है? No problem.
सर वो एप्लीकेशन के ऊपर वो क्या नाम है, हो जाएगी?
Sorry? Sorry?
सर वो आपकी एप्लीकेशन के ऊपर वीडियो अपलोड हो जाएगा Class-10 था सर.
Okay. 16th problem. Now there are last 5 problems left, which are numerical integer type questions. If the circuit is used to amplify the sinusoidal input by the factor of 15, so the gain is 15, and R1 C1 is 10 nanoseconds, then what is the frequency of the sine? So very simple. How do you write gain? Gain is written as V output by V input, or you can write it as impedance of feedback divided by impedance of input. What is in feedback? In feedback there is only one capacitor, so XC1 divided by what is in input. In input only there is one resistor, which is R1. I will provide yesterday's lecture, don't worry. Okay. I will provide both OPAMP lectures because I promised you guys that whoever is not in course, I will provide OPAMP lectures. Okay, don't worry. Okay. Next, then XC1 by R1. Okay, now let's see XC1. What is XC1? J omega C. I'm not interested in phase, so I'm not writing J at this moment. So it is XC1 is 1 by omega C, and what is R1? R1 is simply R1. R1 C1 is 10 nanoseconds and gain is 15. So gain is 15 and R1 C1 is 10 nanoseconds. So 10 to the power minus 8, and then there is omega. And then there is omega. And omega can be written as, then you can find it, right? So you can just do the maths. Rest of the maths you can do. Okay. So it will something comes out with 6.6 mega radians per second. Okay. So very simple problem. Yeah. Again, I don't think I will repeat this problem. So it is a simple problem. You try this now. Okay. Now this thing, did I talk about this? This is, I think, Wien bridge oscillator. So this is, no. Yeah, I think it is Wien bridge oscillator. But what are they asking? What are they asking? Let's see. This is basically known as Wien bridge oscillator. I will send you the lecture for Wien bridge oscillator as well. But I have never seen the question in CSIR, but it can be asked because this time multi-vibrator question was there. I sent you one lecture yesterday to watch as a recommended lecture, and that was a stable mono vibrator. Similarly, this is Wien bridge oscillator, and anyway, let's see. Let's see if we can solve this question based on the current knowledge. So what value of C is required for a sinusoidal oscillation of frequency 1 kilohertz in this following circuit? So the cutoff frequency is given, or frequency is given, and C is asked. We know the formula that F is equals to 1 by 2 pi RC. But we don't know that what is R and what is C. Now we have to take. So always take whatever is given in the feedback. So what is given in the feedback? Okay, so there are many things. R is 1 kilo ohm for both. Luckily, it is 1 kilo ohm for both. But what if it is different? So which resistor you will choose? Even I don't know. I have to look at my notes that which resistor to choose. I think this resistor has no job except to make sure that the current flows to ground or something like that. I don't think this resistor should be there. I think these two has to be taken because these are directly put in the feedback. Always remember, resistor and capacitor has to be taken which are connected in the feedback. So take your R as 1 kilo ohm and you find your C. The frequency is already given 1 kilohertz. So whenever in an OPAMP, the frequency formula is R, it is always 1 by 2 pi omega C or 2 pi RC. Okay. So yesterday we saw this formula. F is equals to 1 by 2 pi RC. If it's a Wien bridge oscillator or if it is high pass filter, low pass filter, frequency formula is this. So just apply this, okay, and you will get your answer. Don't look at this because this is input. Yesterday also we had two inputs in the top. We did not focus on that. We focused on the RC part of the feedback. Okay, good. Then the next, yeah, this is I think this is interesting question. Yeah, please. Yes, tell me.
सर वो क्या ना, मैं निगेटिव जैसे फीडबैक तो सर निगेटिव पार्ट में लेते हैं ना, निगेटिव फीडबैक में, तो जो आर और सी है वो तो पॉजिटिव पार्ट की तरफ है ना, तो
So that is why it is a oscillator. It's not a filter. It's a oscillator. So it will make the oscillations. क्या होगा इसमें, होगा क्या? Let me tell you. You have pointed out very good thing that it's attached to the positive feedback, positive terminal, or you can say non-inverting terminal. So the gain is ideally infinite. Ideally it is infinite, or you can say very high. So if the input voltage is, let's say, very small, 1 millivolt, then the output voltage will go to very high, let's say infinite. But the problem is that it cannot go to infinite. Nothing can go to infinite. So it can go to maximum saturation voltage. What is saturation voltage? Saturation voltage is a voltage which you are giving to an op-amp to operate it, to function it. Usually this is written like this. You see here it is given 15 volt and minus 15 volt. Similarly, in that diagram also there is some saturation voltage, but it is not shown. But it is always there in an op-amp. Okay, so the voltage will cannot go to infinity, so it will go to V saturation. So when the input is positive, it is positive saturation, and when the input is negative, it is minus saturation. So you see it will just keep oscillating between plus saturation and minus saturation, plus saturation, minus saturation. So it will become an oscillator. So it is oscillating between two voltages, V saturation and minus V saturation. So this will be your graph. That is why it is known as Wien bridge oscillator. Yeah, Wien bridge oscillator. Okay, so yeah, that is roughly the idea. Okay. Okay. And since it is oscillating, they are asking you what is the frequency of oscillation. How much is the frequency of oscillation? The op-amp in a figure has an input offset voltage of 5 millivolt. Okay, and the open loop gain of 10,000. Then the magnitude of output voltage will be. So when the gain is so high, so if you multiply 5 millivolt with your gain, means input voltage is 5 millivolt and the gain is 10,000, you will find out that this comes out to be 50 volt. But your answer cannot be more than 15 volt, because 15 volt is a maximum your answer can go. You can go at max to the saturation voltage, not more than that. Otherwise you have an energy crisis. How can you generate, how you can convert 5 millivolt into 50 volt without doing anything? So you cannot do that. You can at max go till V saturation, and that is why your answer to this question will be 15. That's all. So that's a simple concept. Okay, so these are the questions of the positive feedback. So last two questions are from the positive feedback. First 18 questions we did, in all of them there was a negative feedback. Whenever there is a positive feedback, the voltage goes to the saturation voltage. Okay, and if the input is positive, then the output is plus V saturation. If the input is negative, then the output is minus V saturation. Okay. This question, I think again the similar kind of question is an easy one. You can do that. We did many such questions today. Okay. So these were your 20 questions, and I hope that you enjoyed this session, and you can get the recording of this later. Okay. Okay. So I can tell you that I cannot provide the lecture before tomorrow evening because my Wi-Fi has a problem right now. I'm taking the lectures with hotspot basically. But yes, it will be available tomorrow evening. My Wi-Fi will be fixed by tomorrow. Okay. And then I will provide all the 3 lectures altogether. Till now, the students who are already in the course, you know that you can watch the lectures in recording sections. So for you, it will be automatically updated. Okay.